A website says you must prove you are human. It asks you to paste and run an instruction.
That action can open two roads, one leaves Python files and a scheduled task, the other hides its payload in a JPEG and runs mostly in memory.
Both end at stolen browser credentials, session tokens, and documents.
Microsoft reported increased ACR Stealer activity in customer environments from late April through mid-June 2026. In the next 4 minutes, you will learn how its two highlighted ClickFix campaigns move through Windows, where their architectures differ, and which 4 choke points defenders can monitor or block. These are representative chains from Microsoft's reviewed intrusions, not every ACR Stealer technique in the wild. Picture a finance employee searching for a document conversion tool.
A sponsored result opens a fake verification page.
This walkthrough is illustrative, but the mechanism matches Microsoft's observations. The page persuades the user to launch a Windows command.
The attacker does not need to defeat a browser sandbox first. Social engineering turns the user into the execution bridge.
From there, draw the architecture as 4 stages: user action, Windows execution bridge, concealed payload, then credential and document theft.
The two campaigns swap components in the middle, yet converge on the same objective.
That is why a single domain or file hash is a fragile defense.
Road A is heavier on disk and persistence. A command reaches a remote WebDAV share.
In some variants, pushed maps that share to a temporary drive, so remote content appears to run from a local path.
Rundle32 loads a remote DLL, which starts obfuscated PowerShell. PowerShell downloads a packaged payload into a deceptive folder under the user's local app data. A bundled python.exe starts the loader without a visible console, while a disguised scheduled task restores execution when the user signs in. The loader reconstructs its payload at runtime and transfers execution into memory. Microsoft also saw a subset use public blockchain services as dead drop resolvers for follow-on infrastructure.
That subset matters, but it does not make blockchain itself malicious.
Road B trades the Python bundle and scheduled task for a more memory-heavy route. The user action starts MSHTA, which retrieves remote HTA content. VBScript and COM objects decode an obfuscated PowerShell stage. PowerShell then downloads what looks like an ordinary JPEG from an image host.
The script reads hidden data from the image's pixels, decrypts and decompresses it, then resolves Windows APIs at runtime for reflective, in-memory execution. Fewer normal files land on disk, so file-only scanning has less to inspect.
But fileless does not mean invisible.
The process tree, network retrieval, PowerShell behavior, memory activity, and later credential access still leave signals.
Now collapse both roads into 4 choke points.
First, before execution, teach users that a website asking them to paste or run shell, PowerShell, Rundle32, or MSHTA instructions is malicious, and filter low-reputation domains.
Second, at the execution bridge, use application control and attack surface reduction policy to restrict untrusted internet content from reaching script hosts and signed proxy executors. Third, during execution, alert on remote retrieval followed by PowerShell, Python, unusual child processes, suspicious scheduled tasks, time-stumping, or history clearing. Fourth, at the objective, investigate browser database access, copy decryption, document collection, and compression or staging. For our finance employee, if the command ran, isolate the device. Preserve the browser-to-shell process tree. Check PowerShell, Python, MSHTA, Rundle32, scheduled tasks, browser credential store and copy access, and document staging. Rotate exposed credentials and revoke potentially stolen sessions or tokens. A password reset may leave a stolen session alive. There is a trade-off. Blocking these tools everywhere can break legitimate administration and applications. Scope controls by role allow trusted signed workflows and roll out in stages. Behavior chain detections outlast infrastructure changes, but they create noise and need a baseline. Those trade-offs are reason guidance. Microsoft sourced the observed mechanisms and response actions. Remember, 1 lure, 2 roads, 1 destination, 4 choke points. Stop the user action, watch the execution bridge, and protect the credential and data objective. For practical cybersecurity training, see the course links below.